Hey everyone, today we're going to be going over 7.1 and 7.2 exercise 9. And starting with the question, we are given a function y equals e to the power of 2x minus x squared, and the two regions R and S, bounded by this curve and various other horizontal lines. So if you were to break down each part, we see that this function right here is going to be e to the 2x minus x squared, and then that's going to be e to the y equals 2 and y equals 1. So for A, we are asked to find the area of R. So to find the area of region R, we need to find the x values where the curve y equals e to the power of 2x minus x squared intersects the line y equals 2. To do that, we can start off by setting the equation with e to the power of 2x minus x squared equals 2, since the y value is 2. And solving this equation using a calculator gives us values x equals 0.4461 and x equals 1.553. So we can say that this value right here is 0.4461 and this right here is 1.5539. So for simplicity, we can define these points as P and Q. And to find the area, we can use the formula for the area between two curves, and this would be the integral of the upper function minus the lower function. So for region R, the upper boundary would be the curve y equals 2x minus x squared, and the lower boundary is the line y equals 2. And our limits are from P to Q. Therefore, if we were to set up the equation, we can say that area of R equals integral from P to Q e 2x minus x squared minus 2 dx, since it's upper minus lower. And as I explained, the upper will be the curve and the lower will be y equals 2. So if we were to solve this using a calculator, having P and Q as the values we found earlier, P, Q, we can find that the area of R equals 0.514. So our final answer would be 0.514 for the area of R. Now moving on to part B. Part B asks us to find the area of S. And although finding the area of S might seem tricky at first, the key to finding the area of region S is to recognize that S is a part of a larger, easier to define area. So if we see right here, we see that S is part of the integral that includes R and S. So easier way to solve this would be finding the area of the whole region and subtracting R, since we have found the area for R already. So we can find the total area of the entire shape bounded by the curve y equals 2 e to the power of 2x minus x squared and the lowest horizontal line y equals 1, with the limits for this total shape being x equals 0 and x equals 2. We can see this by simply looking at the graph, and we can see that the 2 points x equals 0 and 2 are the points of intersection with y equals 1 and y equals e to the power of 2x minus x squared. So to find the area of the total, we can set up the equation by saying area T for total equals integral 0 to 2 e to the power of 2x minus x squared minus 1 dx. This gives us the total area, and with the total area we can simply subtract r to find the S area. And area of T comes out to be 2.06016. So we can just simply subtract what we found earlier, which is 0.514 from this answer, which will give us 1.546, which means the total area for S is 1.546. Moving on to part C, we need to set up the integral for the volume of the solid generated when region R is rotated about the horizontal line y equals 1, but we do not need to evaluate it. Since we are rotating a region bounded by two functions around the horizontal axes, we will use the washer method. And to state the formula for the washer method, the volume is equals pi integral a to b outer radius squared minus inner radius squared dx. So to apply the formula, we need to identify the components. So from the question, we see that the axis of rotation is y equals 1, which would be this line right here, y equals 1. And the next component would be limits of integration, which would be the x limits of region R, which we already found from part A, which are P and Q. So we know that P is 0.4461 and Q is 1.5539. So if we could just bring that over. Now we will find the outer radius, and the outer radius will be the distance from the axis of rotation to the outermost boundary, which would be the curve y equals e to the power of 2x minus x squared. Now we'll represent the outer radius using green, which would be right there. And since this is the distance, we have to top curve minus the axes, which would be e to the power of 2x minus x squared minus 1. So we will write that down. Outer radius being e to the power of 2x minus x squared minus 1. And for the inner radius, this is the distance from the axis of rotation to the innermost boundary, the bottom line of R, which is y equals 2. So I'll use purple for that, which would be right there. So since this is also a distance, we would have bottom line minus the axes, which would be 2 minus 1. So the inner radius would be 1. So substituting all these components we found in the formula, we see that v equals pi integral 0.4461 to 1.5539, and e to the power of 2x minus x squared minus 1 squared minus 1 squared dx. So that will be the answer for part C, since we are only told to find the integral, not evaluated. Thank you.